This is the video notes for Unit 6, Lesson 6, Quadrilaterals Beyond Definition. It is a practice understanding, so there's nothing new, but we're pulling everything together. It starts with a jump start. In the jump start, you need to give the name of a geometric figure that has the following characteristics. So our first one says, a type of quadrilateral with no lines of symmetry. If we look back in lesson 6.4 and we look through our 4 types of quadrilaterals that we were studying, rectangle, parallelogram, rhombus, and square, we can see that a parallelogram has no lines of symmetry. So that's our first answer. All right, number 2, a type of quadrilateral whose diagonals are its only lines of symmetry. Okay, again, we look back in lesson 6.4 and we're looking at our lines of symmetry. Rectangle has midpoint to midpoint lines of symmetry, but a rhombus has diagonal to diagonal. Okay, so rhombus is our second answer. All right, number 3. A type of quadrilateral where the lines through the midpoints of opposite sides are lines of symmetry. So that was, looking back at 6.4, a rectangle. And it doesn't say only the lines through the midpoints of opposite sides are lines of symmetry. So we could actually say the square also qualifies as this quadrilateral, even though the square has lines of symmetry through the midpoints and the diagonals. But it doesn't say only through the midpoint, so we're going to say rectangle or square. All right, let's go ahead and turn the page. Now we've seen this diagram before, right? We found that many different quadrilaterals possess lines of symmetry and or rotational symmetry. In the following chart, write the names of the quadrilaterals that are being described in terms of their symmetry. Have we seen this chart before? Let's see. Yeah, we saw it at the end of 6.4. So the quadrilateral that just has 180 and 360 rotational symmetry is a parallelogram. Okay, now we get a little bit more. We get 180 and 360 rotational symmetry for both of the next ones. But on this left one, we also get 2 lines of symmetry, which are the diagonals. Okay. And on this right one, we also get 2 lines of symmetry, but these are through the midpoints of the sides. So that's a rectangle. Now, the one that we are studying that has the most symmetry of all of them is a square. So the square goes in this last one. It has 4 angles of rotational symmetry, 90, 180, 270, and 360, so every 90 degrees. And it has 4 lines of symmetry. It has both diagonals and through the midpoints. So what are we seeing next? All right, let's turn the page. So based on the symmetries we've observed in various types of quadrilaterals, we can make claims about other features and properties that the quadrilaterals may possess. Okay, so this is like our summary of all the features of each of our 4 quadrilaterals. So let's talk about a parallelogram first. It is a quadrilateral in which opposite sides are parallel. So that's huge right there. Opposite sides are parallel. What else can we say about parallelograms besides the defining property that opposite sides of the parallelogram are parallel? So we're going to mark it up with arcs and ticks to show these additional properties. All right. So I'm just going to first show the parallel, right? So this is parallel to this one, and it doesn't have to be 2 arrows. It could be one arrow for that matching sides, and I'm going to do 2 arrows for these 2 matching parallel sides. I'm going to also say that these opposite sides are congruent. So those 2 longer ones and then these 2 shorter ones are congruent. And then I'm going to draw in the diagonals. Actually, let's do angles. So this acute angle is congruent to this acute. So those opposite angles are congruent. And this obtuse is congruent to this obtuse. So opposite angles are congruent. Now let's draw in our diagonals. So for our diagonals, we'll go vertex to vertex, vertex to vertex. And it looks as if the diagonals bisect each other. What that means is they cut each other in half. So like this half right here is going to be congruent to this half. And then this half right here is going to be congruent to this half. Okay, so let's make a list of all of our properties for a parallelogram. So our first property that we're going to list is the opposite sides are parallel. And that we already know based on the name, right? But let's record it. Opposite sides are parallel. What else do we know about opposite sides? We also know that they're equal length, right? So they're going to be congruent. So we'll say opposite sides are congruent. Okay. And then we move on to, let's do opposite angles, right? Those opposite angles were congruent. Opposite angles are congruent. And then we had one more. The last one was about the diagonals. The diagonals bisect each other. So this should really have 4 bullet points. Diagonals bisect each other. Remember, bisect means cut in half, so the diagonals cut each other in half. All right, so let's move on to a rhombus. So we've got 4 for parallelogram. And let's see how many we have, properties we have for a rhombus. A rhombus is a quadrilateral in which all 4 sides are congruent. So that's like given for a rhombus. What else can we say besides the defining property that all sides are congruent? So we're going to mark it up and then we're going to list all of them. Okay, so let's first do, remember based on the table on the previous page that anything that's happening to a parallelogram happens to the figures lower down. Like a parallelogram has the least happening to it, but whatever's happening to it is also happening to a rhombus and a rectangle. So let's see if we can add some from the parallelogram to the rhombus. So we know that a parallelogram, opposite sides were parallel. So let's just add that in here, right? We'll do some notation. So this is parallel to this. This is parallel to this. Specifically for a rhombus, all sides are congruent. We could also say opposite sides are congruent, but a more correct phrase would be all sides are congruent. What else can we say? Let's talk about angles. So this obtuse angle right here is going to be congruent to this obtuse angle. This acute is going to be congruent to this acute. Okay, so now let's draw in our diagonals. So from vertex to vertex, that's how we draw in diagonals. So for a rhombus, the diagonals have a lot happening. So just like a parallelogram, the diagonals bisect each other, right? So we could say this is equal to this, and this one is equal to this one. But also, the diagonals are perpendicular, so we can put in 4 right angles in the middle. And the diagonals also bisect both pairs of opposite angles. So, like, let's zoom in here on the right to see what that means. Do you see this blue diagonal? Do you see what it's doing to this angle right here? It is bisecting it. It is cutting it in half. So this angle, this little one, is going to be equal in degrees to this one. Okay. All right. So let's list all of these. It sounds like a lot. So the very first one, what we did was opposite sides are parallel. Opposite sides are parallel. We also know that opposite sides are congruent, and not just opposite sides, all sides. So I'm going to list both of those. Opposite sides are congruent, and all sides are congruent. Okay, so all sides are congruent is more correct than opposite sides are congruent, but we can have both. All right, so that's all about the sides. So let's do angles. So now we've got the opposite angles are congruent. Okay, so that takes care of sides and angles. So now let's do our diagonals. We've got 3 of those. I'm just going to put them over here on the right. Do you see we have like a lot more lines over here? And I'll just add 1, 2, 3 bullet points because we've got 3 bullet points about the diagonals. So our first bullet point about the diagonals was that they bisected each other, right? So they cut each other in half. So diagonals bisect. Let me fix that. There we go. Bisect each other. Okay, our next one was diagonals are perpendicular. They formed those 4 90-degree angles in the middle. Okay, and then our last one about the diagonals was what I was talking about for the opposite angles. The diagonals will bisect both pairs of opposite angles. Bisect both pairs of opposite angles. Okay, so it looks like for a rhombus, we've got 7 additional properties going on. Okay, and this last one, diagonals bisect both pairs of opposite angles. Remember that applies to over here on the right, over here on the left, here on the top, here on the bottom. All of those angles were cut in half or bisected by the diagonals. All right, let's turn the page. Let's do a rectangle. So a rectangle is a quadrilateral in which all 4 angles are congruent, right? We've got 4 congruent angles, and not only that, they're right angles. What else can we say about rectangles besides the defining property that all 4 angles are congruent? So let's go ahead and mark it up with arcs and ticks to show these additional properties. So the first ones that we're going to do, let's do opposite sides are parallel, right? That also applies to this, just like the parallelogram and the rhombus. Opposite angles. No. Opposite sides are congruent. So this short one will be congruent to this one. This long one will be congruent to this one. Opposite angles congruent, and not just that, all angles are congruent. So we can put 4 90-degree angles because they're all congruent, not just opposite, but all. And now let's put in our diagonals. So here's our first diagonal from vertex to vertex. Here's our second. So it looks like our diagonals have two properties. It looks like the diagonals are congruent, right? These two blue lines are going to be the same length, and they also bisect each other. So this length is equal to this length, which is equal to this one, which is equal to this one. All right. Okay, let's go ahead and list all of these. Okay, so we're always starting with the property that parallelogram and rhombus share with a rectangle. We're going to start with opposite sides are parallel. We're going to start with that every time. Opposite sides are parallel. Okay, so same thing like for a a rhombus and a parallelogram. So what else did we say? Opposite sides are parallel, opposite sides are congruent, right? Opposite sides are congruent. Okay. We can also say that opposite angles are congruent. Although, to be like more correct, we would say that all angles are congruent. So let's add that one in. All angles are congruent. So these statements about angles are both true, but the bottom one is like more correct. Okay, let's add in our statements about the diagonals. So we saw that the diagonals are equal length, so diagonals are congruent. I'm going to just use the lines here that I didn't use up, so we'll add our two diagonal statements. So diagonals are congruent. So this is unique to a rectangle. We did not see that in a rhombus or a parallelogram. Okay, and then our last one, diagonals bisect each other, which we did see in a rhombus and a parallelogram. Okay, so that takes care of a rectangle. It's got 6 additional properties. All right, let's use our last one, which is a square. A square is both a rectangle and a rhombus. Oh, so what's that telling you? That's telling you that any of the properties that a rectangle or a rhombus has, the square will also have. So the square is going to have lots of properties. What else can we say about a square? Mark the square below with diagonals, arcs, and ticks to show these additional properties. All right, let's mark up a square. So a square will have opposite sides being parallel, just like all the other shapes. So parallel to this one, and then these two are parallel. A square will have opposite sides congruent, but not just opposite sides congruent, all sides congruent. So let's do a single tick on all the sides. And then a square will also have opposite angles congruent, but not just opposite angles congruent, all angles congruent. So all of these are going to be 90 degree angles, right angles. Okay, now let's mark up the diagonals. So here's my first diagonal, here's my second, vertex to vertex, right? So these diagonals are congruent. They're the same length, but they also bisect each other. So we can put a double tick here, double tick here, double tick here, and double tick here. Not only do they bisect each other, but they meet at the middle, just like a rhombus at 490 degree angles. And then over here on the corner, if we zoom in on this corner angle, what's happening is it's actually, the diagonal is bisecting this angle into two 45 degree angles. Okay, so that is 4 properties for the diagonals. It's kind of a lot. All right, let's go ahead and start listing all our properties for a square. So the first one we always list for any of them is opposite sides are parallel. Opposite sides are parallel. Okay, opposite sides are also congruent. And a better statement, honestly, for opposite sides are congruent are that all sides are congruent. Because that's more true. These are both true, but this one is more accurate. All sides are congruent. Okay, now let's talk about the angles. So opposite angles are congruent. Opposite angles okay, and not just opposite angles are congruent, all angles are congruent. So I'm going to add another bullet point down here that is talking about how they're not just opposite angles are congruent, but all angles are congruent. Okay, we're going to have 4 properties about the diagonals. So I'm going to use the right side of these bullet point lines to list those 4. So here's our 4 diagonal properties. So our first one is going to have to do with how the diagonals are the same length. Diagonals are congruent. Diagonals are congruent. And not only are they the same length, but they bisect each other. So they'll cut each other in half. Diagonals bisect each other. Okay, what else can we say about the diagonals? Just like a rhombus, the diagonals form 4 90-degree angles in the middle. So diagonals are perpendicular. Okay, perpendicular, I'm missing an R. Perpendicular. Okay, and our final property for diagonals is that in the corners, right, at the opposite angles, the diagonals bisect both pairs of opposite angles. Diagonals, that's just like I think that happened with a rhombus. Bisect both pairs of opposite angles. Okay, so for a square, which had the most symmetry, it also has the most properties, which it shares with a lot of the previous shapes. For the lesson summary, in this lesson, we learned about quadrilaterals and how we can classify them in terms of properties that they share with other quadrilaterals, such as congruent opposite sides or angles. I hope this helps you with your practice, and I wish you luck. Thank you.